Hello, welcome back to the midterm review, and we are going to work on the problems for chapter 5 for the midterm review. So there were some things that needed to be crossed out that no longer needs to be here. So number 6 says find the simple interest on a loan of $4,902 at 6.5% for 11 months. So simple interest is we're just looking for the interest, not the future value. So this is going to be 4,902 times the rate of 0.065 times 11 over 12, because it's in time is always in years and we only have 11 months. So this is going to be 4,902 times 0.065 times 11 divided by 12. And that comes out to be $292.08. Number 7 says, find the simple interest on a loan of $3,478 at 7.4% for 88 days. So same formula. This time the principal is 3,478. The rate is 0.074 and 88 days out of 365, because we have to put that in terms of the year. So 7, 8. And it looks like the interest that we're going to owe is $62.05. Number 8 says, what is the present value? What is the present value if you want a future value of $459.57 in 7 months that earns 5.5% simple interest? So we are looking at, this is our usual formula. But this time we want to know what the present value is. So we're going to take the future value of $459.57, and we're going to divide by 1 plus the rate of 0.055 times 7 divided by 12, because it's out of a year. So we need to know what we need to invest. So 459.57 divided by 1 plus 0.055 times 7/12. So we have to put in $445.28. Question number 9. Question number 9 says, find the value of $2,800 at 6% compounded monthly for 12 years, and then how much interest was earned. So the future value Okay, so find the future value. So our future value compounding is going to be our present value times 1 plus our rate divided by 12 for compounding monthly. And then we're going to raise that to the exponent of the compounding monthly times 12 years. So 144 compounding periods. 6 times 12. So it looks like we will then have, after 12 years, $5,742.10. And it says how much interest was earned. So we're going to have to take $5,742.10 and subtract away the $2,000 that we invested, and that's how much we would have earned. So we would have earned $2,942.10. So we over doubled our money. That's a pretty good interest rate, and we compounded monthly. So it's pretty good. Okay, number 10. Yes. Find the future value of $12,903.45 at 6.37% compounded quarterly for 29 quarters. Okay, so we want the future value. So similar to what we just did, we're going to start with 12,903.45 times 1 plus 0.0637 divided by 4, compounding quarterly. So we're compounding very often. And then they already told us the total number of compounding periods, which is 29. So 12,903.45. So after those 29 quarterly compoundings, we will have $20,402.98. Number 11 says, what is the effective rate for the nominal rate of 5% compounded semi-annually? So the effective rate, the formula is 1 plus the rate divided by m to the m minus 1. So that's going to be 1 plus, our rate is 5%. We're compounding semi-annually, so m is 2 to this 2 minus 1. So let's go over here and put this in here. 1 plus 0.05 divided by 2. An extra parenthesis there. So that would be a rate of a simple interest rate of 5.0625% is what we'd have to earn as simple interest to get the same value as a 5% compounding semi-annually. So let's look. Number 12 says, find the present value of 42,000 in 7 years, 12% compounded monthly. So we're going to have to take our present value, is what we're searching for. And so we're going to take our future value and divide by our compounding piece. So we're compounding monthly for 7 years. Okay, so that would be 42,000 divided by 1 plus 0.12 divided by 12. to the 12 times 7. And remember your exponent, that 12 times 7 right here, that needs to be in parentheses. So there it is right here. 42,000 divided by that is, we would have to put in $18,207.65. So let's see, over here, number 13. What is the future value of $4,000 deposited at the end of each quarter? So this is an annuity because we're making deposits at the end of each quarter for 8 years. Money earns 6% compounding quarterly. Okay, so we are going to put in $4,000 as our payment. And we have 1 plus our rate divided by 4 because we're compounding quarterly. And this is our quarterly interest rate. And then we're going to raise that to the 4 times 8 because we're compounding quarterly for 8 years. And that is right there in Desmos. And it looks like we would have $162,753.15 right here in blue. Right here in blue. Let's look at number 14. It says, what amount should be deposited into a sinking fund to accumulate 57,000 if it earns 6% compounded semi-annually for 8.5 years? So we know what we want to have at the end, the future value. We want to know what our monthly payment needs to be. So we have to take our future value and divide. So the 57,000 divided by the 1 plus our compounding rate, and it's semi-annual, to the 2 for the semi-annual times the 8.5 years. And that gets divided by the interest rate, semi-annual interest rate. And that comes out to be, I would need to do payments of $2,619.29 twice a year. That's pretty good money. Because twice a year is every 6 months. So if we divide it by 6 months, that's only not even $500, about $420 a month. And we would have 57,000 because they're compounding twice a year. That is awesome. Okay. 15 says, what is the present value of the ordinary annuity car loan? So like a car loan, if you can budget payments of $877.34 monthly for 17 months at 6.4% compounding monthly. So 17 months is only a year and 5 months. So we have to remember that. It's not very long. You want to have that paid off by. So that's why you're willing to make more expensive payments, maybe. So we're going to put in our payments. So this would be we want to find out the present value, what we're going to borrow. This would be our potential loan. If we can afford $877.34. 1 minus 1 plus 0.064 divided by 12 monthly. And here it is. And then our exponent is to the negative 12 because it's monthly payments. Then we have to remember that it's 17 divided by 12 years. So notice that up here. So the loan amount we can afford, and that's including interest, right? That would be $14,222.42. And that's what it's totally worth. That's what you'd be paying after all of your payments. So that's how they figure out your payments. Your loan amount be $14,222.42. Okay. So the problems are up here at the top of the page. So number 16 is, how much would you need in an account to be able to make quarterly withdrawals? So we want to pull out $800 for 4 years with an interest rate of 4.6% compounded quarterly. So we want to pull out $800. So it says, how much would you need in an account to be able to make quarterly withdrawals? So what do I need in my account now if I would like to make quarterly withdrawals to myself? And so this is the formulas that I've been using are on page 292 in the 11th edition, or 10th edition, I mean. 10th edition. For those watching. So interest rate is 4.6% compounding quarterly, and we're going to make $800 withdrawals. And so this is to be a negative 4 times 4. So a negative 16. And that would be 11,630 and 63 cents. And then the last problem says, what would your monthly payment be if you purchased a home for $125,000 if you put 20% as a down payment for 30 years at a rate of 7.21%? That's the going interest rate right now. So they went way up. So first of all, we have to find out 20% of 125,000 is going to be $25,000 down payment. So you need to have $25,000 as your down payment. So that means you're going to take out a loan for 125,000 minus the 25,000. So your loan is still going to be for 100,000. Now this is if you can find a house for 125,000. Okay, so you're going to borrow 100,000. So your 100,000 and then you're going to, now I have it kind of upside down, but it really could be what I'm going to draw on the paper here, which would be your 0.0721 over your 12 monthly payments divided by 1 minus times 1 plus 0.0271 divided by 12 to the negative 12 times 30, because there's 360 payments in a 30-year loan. This is 12 times 30. And so this would be a monthly payment of $679.47. But if you think about it, if you can find a house and you can do that, you'd need $2,500 down. Let's say you only had to put 5% down. So 5% down would be $6,250. So let's say you saved up that and you were going to buy this $125,000 house first, and you put 5% down, and now you were going to borrow $118,750. Your payments would still only be $806.87, which is a lot less than most one-bedroom apartments right now. So if you can save up the $6,250, it's definitely in your best interest to purchase a home. There you go. And home prices are dropping, unfortunately, because the economy is not as great right now. So catch me back for some more videos and let me know if you need help with anything.